This is Bhavya Dutta, working as a lecturer in Devi Mahalakshmi Polytechnic College. Today I'm going to take a lecture on first chapter of microprocessor of second bit. So this is the second bit of first chapter, that is types of buses and types of architecture. Second bit and third bit, that is types of buses comes under the second bit of first chapter, and types of architecture comes under the third bit of first chapter. So we'll discuss about this one by one. So first we'll discuss about the basic concept of bus. So a bus is a high speed internal connection. So buses are used to send control signals and data between the processor and other components. So bus is a group of wires which function as a communication canal or communication channel or means for the transfer of data. So bus is like a communication media through which we can transfer the data. These buses comprises of 8-bit, 16-bit or more cables. They consist of 8 cables or 16 cables. As a result, a bus can bear 8 bits or 16 bit altogether. So if the data is of 8 bit, then you are supposed to use 8 cables, bus of 8 cables. If the data is of 16 bit, then you are supposed to use 16 your bus of 16 cables. The system bus consists of all the support devices to the CPU. If you look at this diagram, the system bus. So here this system bus is directly connected to the CPU, memory and input output. One of the main objectives of a bus is to minimize the lines that are needed for the communication. In 8051, the system bus consists of an 8-bit data bus, 16-bit address bus and control bus. So we'll discuss about these three buses one by one. So first is the data bus. So the data bus is bidirectional, on which data or instruction codes are transferred into the microprocessor. If you can look at this diagram, this system bus, here the data bus is, here the arrow in both the side arrow is there. So that means what, it is bidirectional, means you can send the data from system bus to CPU or from CPU to system bus. So here the data are transferred into that microprocessor or CPU on which the result of an operation is sent out from the microprocessor to the memory or input output. Depending on the particular microprocessor, the data bus can handle 8-bit or 16-bit data. Using data bus, CPU either gets data from the device or sends data to device. Next was the address bus. So this address bus, it is a unidirectional, as in one side arrow is there. So it is unidirectional, over which the microprocessor sends an address code to the memory or input output. The size of the address bus is specified by the number of bits it can handle. So if the address bus can handle as the data bus is address bus is handle 16 bit of data, 16 cables are there, so you need 16 cables. The more bits are there in the address bus, the more memory locations a microprocessor can access. A 16-bit address bus is capable of addressing 64K addresses. It is also utilized to transmit the address from the CPU to memory. Next is the control bus. The control bus is used by the microprocessor to send out or receiving timing, as CPU is a bidirectional, control bus is a bidirectional. So it is used by the microprocessor to send out or receive timing and control signals in order to coordinate and regulate its operation and to communicate with other devices, that is memory or input output. It provides read or write signals to the device to indicate that the CPU is asking for information or sending it information. The CPU transmits a variety of control signals to components and devices to transmit control signals to the CPU using the control bus. One of the main objectives of a bus is to minimize the lines that are needed for the communication. So these are all about your buses used in the 8051 microcontroller. Now let's just take a minute and try to answer this question. Your 8051 microcontroller has what type of how many bits of data bus? The 8051 microcontroller is a dash 8-bit microcontroller, and which bus is used to read and write operation on data? As all the answers are given here, so 8051 microcontroller has your 8-bit data bus. 8051 microcontroller itself is a 8-bit microcontroller, and your data bus is used to read and write operation on data. Now let's just move forward and talk about the types of architecture used in 8051 microcontroller or computer architecture. So this computer architecture is divided into two types, Harvard architecture and von Neumann architecture. So we'll discuss about these two architectures in the upcoming lectures. Now the Harvard architecture, first we'll need to talk about the computer architecture. So computer architecture comprises rules, methods and procedures that describe the execution and functionality of the entire computer system. So in general terms, we can say the computer architecture refers to how a computer system is designed using compatible technologies. The 8051 microcontrollers work with 8-bit data bus. So they can support external data memory up to 64K, and 64K like 2 raised to 8. If we 8-bit data bus means what? You have to 2 raised to 8 is equal to 64. So it will the data memory is up to 64K, and external memory, program memory, is also 64K at best. So in total it can support 128K of external memory. So when data and code, when both data and code lie or located in the same or different memory blocks, if data and code lie in different memory blocks, then the architecture is called as Harvard architecture. And in case when data and code lie in the same memory block, then the architecture is known as von Neumann architecture. Now we'll talk about the Harvard architecture. So this is the Harvard architecture. So here if you look at this diagram, here Harvard architecture consists of code and data which is located in distinct or different memory locations. So it requires a separate memory block for data and instruction. So if you can see here, that's two different blocks are given. So here instruction memory is different and data memory is different. So for the two different data, for both code and data, we need two different memory locations. So it requires a separate memory block for data and instruction. It contains data storage within the CPU, and a single collection of clock cycle is needed. The data accessibility in one memory is done by a single memory location in the case of Harvard architecture. Here programs needed to be loaded by an operator, and the processor could not boot itself here. In a Harvard architecture, there is no need to make the two memories share properties. So here as two memory locations are given, so instruction memory their location is different and data memory location is different, so there is no need to share the memories. Next is the von Neumann architecture. So this is the von Neumann architecture. So if you can look at this diagram here, this von Neumann architecture was first proposed by a computer scientist, John von Neumann. After his name, this architecture name has been given as von Neumann architecture. It renders a unique design for the electronic digital system, which has the following components. It has a central processing unit with the arithmetic and logical unit, and processors with attached registers. A memory that can store data and instruction. So here both data and code or instructions are located in the same memory location. Then there will be external mass storage or secondary storage. A control unit will be there with the ability to hold instructions in the program counter or instruction register. And lastly, input and output mechanisms and peripherals. So this is all about your Harvard and von Neumann architecture. So there will be a question in your examination for 4 marks related to explain Harvard architecture or explain von Neumann architecture. So the diagram will be of 2 marks and your explanation will be of 2 marks. And there will be a question in your examination related to the comparison between von Neumann and Harvard architecture. So we're going to see that, and this question will be asked for 4 marks or 2 marks or 6 marks. If it is for 4 marks, then you have to compare 4 different comparisons. So von Neumann and Harvard architecture comparison. So under pure von Neumann architecture, the CPU can be either reading an instruction or reading or writing data from or to the memory. Both cannot occur at the same time here since the instruction and data use the same bus system. Whereas in a computer, in a Harvard architecture, CPU can both read and write and perform the instruction as both data and memory, both data and instruction are located in two different memory locations. Von Neumann architecture is much slower as it has a single communication pathway, and a Harvard architecture is faster than von Neumann for a given circuit complexity because instruction fetches and data access do not contain for a single memory pathway. A von Neumann architecture machine does not have distinct code and data address space, whereas a Harvard architecture machine has distinct code and data address spaces. Von Neumann architecture is not possible to have two separate memory systems for a von Neumann architecture, whereas in Harvard architecture it has two separate memory systems for separate memory locations for data and instruction. Von Neumann architecture usually have a single unified cache which stores both instruction and data, and Harvard architecture usually have a multiple cache which stores both instruction and data separately. In von Neumann architecture, it needs external memory all the time, and in Harvard architecture, it may not need external memory all the time. So these are the comparison between Harvard and von Neumann. If the question is of 6 marks, then you have to write down at least 6 points related to von Neumann and Harvard. If it is asking, if the question is of 4 marks, then you need to write or mention 4 points related to von Neumann and Harvard architecture. Now let's just take a minute and try to answer this question. Which architecture provides separate buses for program and data memory? Which architecture is followed by general purpose microprocessors, and how many types of architectures are available for designing a device that is able to work on its own? As all the answers are given here, I'll explain it. Which architecture provides separate bus for program and data? That is Harvard architecture. Which architecture is followed by general purpose microprocessor? That is von Neumann architecture. And how many types of architectures are available for designing a device that is able to work on its own? Two architectures, that is von Neumann and Harvard architecture. I hope you have understood the concept of types of buses and types of architectures. Thank you.